Hi friends, welcome to follow up. Today let's have a look at problem 198, house robber. So this is a daily challenge problem. So here we are going to practice dynamic programming. So actually there are several follow-up questions on house robber. So basically they can solve similarly. So here first we are going to digest the requirements, and then we look at the strategy or idea, and finally we look at the coding. So first let's look at the problem digest. So here we have a robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping us from robbing each of them is that adjacent houses cannot be robbed simultaneously, right? So given an integer array nums representing the amount of money of each house, return the maximum amount of money we can rob tonight without alerting the police. So here are two examples. We can look at example 1. So we cannot rob the houses with money 2 and 3 simultaneously, right? So we can rob 1 and with 3, so we get 4, right? So in example 1, so the output is 12. So for example, you can rob this guy 2 and then 9 and then 1, so you get 12. So this problem actually is a small size problem. So the length of this list is bounded above by 100, and each house contains non-negative money. So with that said, we are ready to look at the solution or the idea. So here you can see that there are quite a number of similar problems. You can practice more, right? So here what we are going to do is the typical dynamic programming. So I'm going to use two lists as a dynamic programming table. So here, rob I, we're going to represent the maximum money up to house I if we rob house I, right? Non-rob is the maximum money we can get up to house I if we not rob this house, right? Then the DP update rule is given here, very simple, right? So I change nums to be 8 just for convenience of writing. So here, the money we can get if we rob houses I plus 1 is the money at houses I plus 1 and plus non-rob I, right? You can interpret from its meaning, because we cannot rob I if we have robbed I plus 1. Well, non-rob I plus 1 can be, we can choose to rob house I or not, right? So because we do not rob house I plus 1, we do not collect the money there. So the return will be the max of rob I. It means that we can collect the money at house I. This one means we do not collect the money at house I, right? So finally, we just need to return the max between rob -1 and non-rob -1, the last element, right? So here in this video, I'm going to write two solutions with O of n. See, n is the length of the capital A or the list. So for spaced complexity, so a very easy exercise is you can optimize to make O1 space, right? So the complexity for sure is linear, right? So first I'm going to get the length of this list, right? Then we can initialize the rob, so times m, and non-rob times n times 0 times n again. So if you do not, at the very beginning, at the index 0, if you do not rob, the money will remain 0, right? So the rob, if you want to collect the money at house at the index 0, you get say A naught, right? Then because non-rob at 0 is already 0, we don't need to reinitialize or modify that. And then basically it's for the DP update rule. So for I in range, so from 1 to n, right? Then rob, so I. So notice that we start the index from 1. So I minus 1 will be inbound, right? So we just need to translate these two rules, right? If we rob I, we can collect the money at this house, and then we get the maximum money. We do not rob house I minus 1, right? Because we have already robbed house I, we cannot rob house I minus 1. Then non-rob I will be the max, so we can decide, we can choose to rob I minus 1 or not, right? If we rob I minus 1, so we get rob I minus 1. If not, it's non-rob I minus 1, right? So after this, we just need to return rob -1 and non-rob -1. So we just need to return the maximal of the two. So let's give a test. Yeah, it passes the first example. Now let's look at the generic case. It passes all the cases. For clarity, you can actually walk through, for example, example 1 or example 2 here. But because it's so easy logically, so we can just print out the two list. Let's see, rob print. So here I'm just printing out their final state, right? So let's test. So you get this 1 2 4 3 0 1 2 4. You get 4, right? So if you try this one, let's see. Let's see what we get. So this one's 12 and it's 11, right? So it means that we need to choose the last one. Then we can get this one, we can get this one. From the content of the list, we can actually retrieve possible ways to collect the money. So with that said, we finished one solution format. So here I can do another format, because here I'm isolated the two, rob and non-rob. So we can, let's copy this one. I'm going to call this one version v1, right? So if we want to use one list, so we can do something like this. So we can do dp, let's see, we have 0 times n for a dummy index in range 2. So we can interpret, see here, dp not as the rob and dp1 as non-rob, right? So here rob will be changed to be, say, dp not. So also we need to do some initialization. So we just need to do dp0 equals a1, a0. But for dp, so there's 0. It means this line, let me use a star, corresponds to here, right? And then what we are going to do, we just need to change this one. Non-rob corresponds to dp1, right? So non-rob, this corresponds to dp1, and then this corresponds to dp0, and this corresponds to dp1, right? So then we just need to print out the dp information, right? So dp, and then we just need to return, so here dp0 -1 and dp1 -1. Let's do a quick test. I have changed this one to be v1, right? So let's test it. Yeah, it passes all the cases. Now let's look at the generic case. Yeah, it passes all the cases. So this is just for pedagogical purpose. So a very easy exercise. So rewrite the codes below to make them O1 in space, right? So this is actually very easy. You just need to introduce some temporary variable, right? Because essentially we just need to track the current state and then return. So with that said, I guess that's about it for this this easy or I would say very direct problem for now, right?